Section 43 of the Library of the World's Best Literature, Ancient and Modern, Volume 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Linda Dodge. Library of the World's Best Literature, Ancient and Modern, Volume 1, Section 43, Selected Works by Charles Grant Allen. Charles Grant Allen, 1848 to 1899. The Irish-Canadian naturalist, Charles Grant Blair Findlay Allen, who turns his industrious hand with equal facility to scientific writing, to essays, short stories, botanical treatises, biography, and novels, is known to literature as Grant Allen, as Arbuthnot Wilson, and as Cecil Power. His work may be divided into two classes, fiction and popular essays. The first shows the author to be familiar with varied scenes and types, and exhibits much feeling for dramatic situations. His list of novels is long, and includes, among others, Strange Stories, Babylon, This Mortal Coil, The Tents of Shem, The Great Taboo, Recalled to Life, The Woman Who Did, and The British Barbarians. In many of these books he has woven his plots around the psychological theme, a proof that science interests him more than invention. His essays are written for unscientific readers, and carefully avoid all technicalities and tedious discussions. Most persons, he said, would much rather learn why birds have feathers than why they have a keeled sternum, and they think that the origin of bright flowers far more attractive than the origin of monocotyledonous seeds or esogenous stems. Grant Allen was born in Kingston, Canada, February 24th, 1848. After graduation at Merton College, Oxford, he occupied for 4 years the chair of Logic and Philosophy at Queen's College, Spanish Town, Jamaica, which he resigned to settle in England, where he now resides. Early in his career he became an enthusiastic follower of Darwin and Herbert Spencer, and published the attractive books entitled Science in Arcady, Vignettes from Nature, The Evolutionist at Large, and Colin Clout's Calendar. In his preface to Vignettes from Nature, he says that the essays are written from an easygoing, half scientific, half aesthetic standpoint. In this spirit he rambles in the woods, in the meadows, at the seaside, or upon the heather-carpeted moor, finding in such expeditions material and suggestions for his lightly moving essays, which expound the problems of nature according to the theories of his acknowledged masters. A fallow deer grazing in a forest, a wayside berry, a guelder rose, a sportive butterfly, a bed of nettles, a falling leaf, a mountain tarn, the hole of a hedgehog, a darting hummingbird, a ripening plum, a clover blossom, a spray of sweetbriar, a handful of wild thyme, or a blaze of scarlet geranium before a cottage door, furnish him with a text for the discussion of those biological and cosmical doctrines which have revolutionized the thought of the 19th century, as he says in Substance. Somewhat more scientific are psychological aesthetics, the color sense, the color of flowers, flowers and their pedigrees, and still deeper is Force and Energy, 1888, a theory of dynamics in which he expresses original views. In Psychological Aesthetics, 1877, he first seeks to explain such simple pleasures in bright color, sweet sound, or rude pictorial imitation as delight the child and the savage, proceeding from these elementary principles to the more and more complex gratifications of natural scenery, painting, and poetry. In the color sense, he defines all that we do not owe to the color sense. For example, the rainbow, the sunset, the sky, the green or purple sea, the rocks, the foliage of trees and shrubs, hues of autumn, effects of iridescent light, or tints of minerals and precious stones, and all that we do owe, namely, the beautiful flowers of the meadow and the garden roses, lilies, cowslips, and daisies, the exquisite pink of the apple, the peach, the mango, and the cherry, with all the diverse artistic wealth of oranges, strawberries, plums, melons, brambleberries, and pomegranates, the yellow, blue, and melting green of tropical butterflies, the magnificent plumage of the toucan, the macaw, and the cardinal bird, the lory and the honeysucker, the red breast of our homely robin, the silver or ruddy fur of the ermine, the wolverine, the fox, the squirrel, and the chinchilla, the rosy cheeks and pink lips of the English maiden, the whole catalogue of dyes, paints, and pigments, and last of all, the colors of art in every age and nation, from the red cloth of the South Seas, the lively frescoes of the Egyptian, and the subdued tones of Hellenic painters, to the stained windows of Poictiers and the Madonna of the Sistine Chapel. Besides these books, Mr. Allen has written for the series called English Worthies, a sympathetic life of Charles Darwin, 1885. The coloration of flowers. From The Colors of Flowers. The different hues assumed by the petals are all thus, as it were, laid up beforehand in the tissues of the plant, ready to be brought out at a moment's notice. And all flowers, as we know, easily sport a little in color. But the question is, do their changes tend to follow any regular and definite order? Is there any reason to believe that the modification runs from any one color toward any other? Apparently there is. The general conclusion to be set forth in this work is the statement of such a tendency. All flowers, it would seem, were in their earliest form yellow. Then some of them became white. After that, a few of them grew to be red or purple. And finally, a comparatively small number acquired various shades of lilac, mauve, violet, or blue. So that if this principle be true, such a flower as the harebell will represent one of the most highly developed lines of descent, and its ancestors will have passed successively through all the intermediate stages. Let us see what grounds can be given for such a belief. Some hints of a progressive law in the direction of a color change from yellow to blue are sometimes afforded to us even by the successive stages of a single flower. For example, one of our common little English forget-me-nots, Myosotis versicolor, is pale yellow when it first opens, but as it grows older it becomes faintly pinkish, and ends by being blue like the others of its race. Now this sort of color change is by no means uncommon, and in almost all known cases it is always in the same direction, from yellow or white through pink, orange, or red to purple or blue. For example, one of the wallflowers, Cheranthus chimolio, has at first a whitish flower, then a citron yellow, and finally emerges into red or violet. The petals of Stytidium fructicosum are pale yellow to begin with, and afterward become light rose-colored. An evening primrose, Oenothera tetraptera, has white flowers in its first stage and red ones at a later period of development. Cobea scandens goes from white to violet. Hibiscus mutabilis from white through flesh-colored to red. The common Virginia stock of our gardens, Malcolmia, often opens of a pale yellowish green, and then becomes faintly pink, and afterwards deepens into bright red, and fades away at the last into mauve or blue. Fritz Müller's lantana is yellow on the first day, orange on its second, and purple on the third. The whole family of Boraginaceae begin by being pink and end with being blue. The garden convolvulus opens a blushing white and passes into full purple. In all these and many other cases, the general direction of the changes is the same. They are usually set down as due to varying degrees of oxidation in the pigmentary matter. If this be so, there is a good reason why bees should be especially fond of blue, and why blue flowers should be especially adapted for fertilization by their aid. For Mr. A.R. Wallace has shown that color is most apt to appear or vary in those parts of plants or animals which have undergone the highest amount of modification. The markings of the peacock and the Argus pheasant come out upon their immensely developed secondary tail feathers or wing plumes. The metallic hues of sunbirds or hummingbirds show themselves upon their highly specialized crests, gorgets, or lappets. It is the same with the hackles of fowls, the head ornaments of fruit pigeons, and the bills of toucans. The most exquisite colors in the insect world are those which are developed on the greatly expanded and delicately feathered wings of butterflies, and the eye spots which adorn a few species are usually found on their very highly modified swallow-tail appendages. So too with flowers. Those which have undergone most modification have their colors most profoundly altered. In this way, we may put it down as a general rule, to be tested hereafter, that the least developed flowers are usually yellow or white. Those which have undergone a little more modification are usually pink or red, and those which have been most highly specialized of any are usually purple, lilac, or blue. Absolute deep ultramarine probably marks the highest level of all. On the other hand, Mr. Wallace's principle also explains why the bees and butterflies should prefer these specialized colors to all others, and should therefore select those flowers which display them by preference over any less developed types. For bees and butterflies are the most highly adapted of all insects to honey-seeking and flower-feeding. They have themselves on their side undergone the largest amount of specialization for that particular function, and if the more specialized and modified flowers, which gradually fitted their forms and the position of their honey glands to the forms of the bees or butterflies, showed a natural tendency to pass from yellow through pink and red to purple and blue, it would follow that the insects which were being evolved side by side with them, and which were aiding at the same time in their evolution, would grow to recognize these developed colors as the visible symbols of those flowers from which they could obtain the largest amount of honey with the least possible trouble. Thus it would finally result that the ordinary unspecialized flowers, which depended on the small insect riffraff, would be mostly left yellow or white. Those which appealed to the rather higher insects would become pink or red, and those which laid themselves out for bees or butterflies, the aristocrats of the arthropodous world, would grow for the most part to be purple or blue. Now this is very much what we actually find to be the case in nature. The simplest and earliest flowers are those with regular, symmetrical open cups, like the ranunculus genus, the potentillas, and the alsine or chickweeds, which can be visited by any insects whatsoever, and these are in large part yellow or white. A little higher are flowers like the campions, or selenoia, and the stocks, Matthiola, with more or less closed cups, whose honey can only be reached by more specialized insects, and these are oftener pink or reddish. More profoundly modified are those irregular, one-sided flowers, like the violets, peas, and orchids, which have assumed special shapes to accommodate bees and other specific honey seekers, and these are often purple and not unfrequently blue. Highly specialized in another way are the flowers like the harebells, Campanulaceae, scabious, dipsacoya, and the heaths, Ericacoya, whose petals have all coalesced into a tubular corolla, and these might almost be said to be usually purple or blue. And finally, highest of all, are the flowers like labiates, rosemary, salvia, etc., and speedwells, veronica, whose tubular corolla has been turned to one side, thus combining the united petals with the irregular shape, and these are almost invariably purple or blue. Among the heather, from The Evolutionist at Large. I suppose even that apocryphal person, the general reader, would be insulted at being told at this hour of the day that all bright-colored flowers are fertilized by the visits of insects, whose attentions they are especially designed to solicit. Everybody has heard over and over again that roses, orchids, and columbines have acquired their honey to allure the friendly bee, their gaudy petals to advertise the honey, and their diverse shapes to ensure the proper fertilization by the correct type of insect. But everybody does not know how specifically certain blossoms have laid themselves out for a particular species of fly, beetle, or tiny moth. Here on the higher downs, for instance, most flowers are exceptionally large and brilliant, while all alpine climbers must have noticed that the most gorgeous masses of bloom in Switzerland occur just below the snow line. The reason is that such blossoms must be fertilized by butterflies alone. Bees, their great rivals in honey sucking, frequent only the lower meadows and slopes, where flowers are many and small. They seldom venture far from the hive or the nest, among the high peaks and chilly nooks where we find those great patches of blue gentian or purple anemone, which hang like monstrous breadths of tapestry upon the mountain sides. This heather here, now fully opening in the warmer sun of the southern counties, is still but in the bud among the Scotch hills, I doubt not, specially lays itself out for the honey bee, and its masses form almost his highest pasture grounds. But the butterflies, insect vagrants as they are, have no fixed home. They therefore stray far above the level at which bee blossoms altogether cease to grow. Now the butterfly differs greatly from the bee in his mode of honey hunting. He does not bustle about in a business-like manner from one buttercup or dead nettle to its nearest fellow, but he flits joyously, like a sauntering straggler that he is, from a great patch of color here to another great patch at a distance, whose gleam happens to strike his roving eye by its size and brilliancy. Hence, as that indefatigable observer, Dr. Hermann Müller, has noticed, all alpine or hilltop flowers have very large and conspicuous blossoms, generally grouped together in big clusters, so as to catch a passing glance of the butterfly's eye. As soon as the insect spies such a cluster, the color seems to act as a stimulant to his broad wings, just as the candlelight does to those of his cousin, the moth. Off he sails at once, as if by automatic action, towards the distant patch, and there both robs the plant of its honey, and at the same time carries to it on his legs and head, fertilizing pollen from the last of its congeners, which he favored with a call. For of course both bees and butterflies stick, on the whole, to a single species at a time, or else the flowers would only get uselessly hybridized, instead of being impregnated with pollen from other plants of their own kind. For this purpose it is that most plants lay themselves out to secure the attention of only 2 or 3 varieties among their insect allies, while they make their nectaries either too deep or too shallow for the convenience of all other kinds. Insects, however, differ much from one another in their aesthetic taste, and flowers are adapted accordingly to the varying fancies of the different kinds. Here, for example, is a spray of common white galium, which attracts and is fertilized by small flies, who generally frequent white blossoms. But here again, not far off, I find a luxuriant mass of the yellow species, known by the quaint name of lady's bedstraw, a legacy from the old legend which represents it as having formed Our Lady's bed in the manger at Bethlehem. Now, why has this kind of galium yellow flowers, while its near kinsman yonder has them snowy white? The reason is that lady's bedstraw is fertilized by small beetles, and beetles are known to be one of the most color-loving races of insects. You may often find one of their number, the lovely bronze and golden-mailed rose-chafer, buried deeply in the very center of a red garden rose, and reeling about when touched as if drunk with pollen and honey. Almost all the flowers which beetles frequent are consequently brightly decked in scarlet or yellow. On the other hand, the whole family of the umbellets, those tall plants with level bunches of tiny blossoms, like the fool's parsley, have all but universally white petals, and Müller, the most statistical of naturalists, took the trouble to count the number of insects which paid them a visit. He found that only 14% were bees, while the remainder consist of many miscellaneous small flies and other arthropodous riffraff, whereas in the brilliant class of composites, including the asters, sunflowers, daisies, dandelions, and thistles, nearly 75% of the visitors were steady, industrious bees. Certain dingy blossoms which lay themselves out to attract wasps are obviously adapted, as Müller quaintly remarks, to the less aesthetically cultivated circle of visitors. But the most brilliant among all insect-fertilized flowers are those which specially affect the society of butterflies, and they are only surpassed in this respect throughout all nature by the still larger and more magnificent tropical species, which owe their fertilization to hummingbirds and brush-tongued lories. Is it not a curious, yet a comprehensible circumstance, that the taste which thus show themselves in the development by natural selection of lovely flowers should also show themselves in the marked preference for beautiful mates? Poised on yonder sprig of harebell stands a little purple-winged butterfly, one of the most exquisite among our British kinds. That little butterfly owes its own rich and delicately shaded tints to the long selective action of 1,000,000 generations among its ancestors. So we find throughout that the most beautifully colored birds and insects are always those which have had the most to do with the production of bright-colored fruits and flowers. The butterflies and rose beetles are the most gorgeous among insects. The hummingbirds and parrots are the most gorgeous among birds. Nay, more exactly like effects have been produced in 2 hemispheres on different tribes by the same causes. The plain brown swifts of the north have developed among tropical West Indian and South American orchids the metallic gorgets and crimson crest of the hummingbird, while a totally unlike group of Asiatic birds have developed among the rich flora of India and the Malay archipelago the exactly similar plumage of the exquisite sunbirds. Just as bees depend upon flowers and flowers upon bees, so the color sense of animals has created the bright petals of blossoms, and the bright petals have reacted upon the taste of the animals themselves, and through their taste upon their own appearance. The heron's haunt. From Vignettes from Nature. Most of the fields on the countryside are now laid up for hay, or down in the tall homing corn, and so I am driven from my accustomed botanizing grounds on the open, and compelled to take refuge in the wild bosky moorland back of Hole Common. Here, on the edge of the copse, the river widens to a considerable pool, and coming upon it softly through the wood from behind, the boggy, moss-covered ground masking and muffling my footfall, I have surprised a great, graceful, ash and white heron, standing all unconscious on the shallow bottom, in the very act of angling for minnows. The heron is a somewhat rare bird among the more cultivated parts of England, but just hereabouts we get a sight of one not infrequently, for they still breed in a few tall ash trees at Chilcombe Park, where the lords of the manor in medieval times long preserved a regular heronry to provide sport for their hawking. There is no English bird, not even the swan, so perfectly and absolutely graceful as the heron. I am leaning now breathless and noiseless against the gate, taking a good look at him as he stands half knee deep on the oozy bottom, with his long neck arched over the water, and his keen purple eye fixed eagerly upon the fish below. Though I am still 20 yards from where he poses lightly on his stilted legs, I can see distinctly his long pendant snow-white breast feathers, his crest of waving black plumes falling loosely backward over the ash-gray neck, and even the bright red skin of his bare legs just below the feathered thighs. I dare hardly move nearer to get a closer view of his beautiful plumage, and still I will try. I push very quietly through the gate, but not quite quietly enough for the heron. One moment he raises his curved neck and poises his head a little on one side to listen for the direction of the rustling. Then he catches a glimpse of me as I try to draw back silently behind a clump of flags and nettles, and in a moment his long legs gives him a good spring from the bottom. His big wings spread with a sudden flap skywards, and almost before I can note what is happening, he is off and away to leeward, making a bee-line for the high trees that fringe the artificial water in Chilcombe Hollow. All these wading birds, the herons, the cranes, the bitterns, the snipes, and the plovers, are almost necessarily, by the very nature of their typical conformation, beautiful and graceful in form. Their tall, slender legs, which they require for wading, their comparatively light and well-poised bodies, their long, curved, quickly darting necks and sharp beaks, which they need in order to secure their rapidly swimming prey, all these things make the waders, almost in spite of themselves, handsome and shapely birds. Their feet, it is true, are generally rather large and sprawling, with long, widespread toes, so as to distribute their weight on the snowshoe principle, and prevent them from sinking in the deep, soft mud upon which they tread. But then we seldom see the feet, because the birds, when we catch a close view of them at all, are almost always either on stilts in the water or flying with their legs tucked behind them, after their pretty rudder-like fashion. I have often wondered whether it is this general beauty of form in the waders which has turned their aesthetic taste, apparently, into such a sculpturesque line. Certainly it is very noteworthy that whenever among this particular order of birds we get clear evidence of ornamental devices, such as Mr. Darwin sets down to long exerted selective preferences in choice of mates, the ornaments are almost always those of form rather than those of color. The waders, I sometimes fancy, only care for beauty of shape, not for beauty of tint. As I stood looking at the heron here just now, the same old idea seemed to force itself more clearly than ever upon my mind. The decorative adjuncts, the curving tufted crest on the head, the pendant silvery gorget on the neck, the long ornamental quills of the pinions, All look exactly as if they were deliberately intended to emphasize and heighten the natural gracefulness of the heron's form. May it not be, I ask myself, that these birds, seeing one another's statuesque shape from generation to generation, have that shape hereditarily implanted upon the nervous system of the species, in connection with all their ideas of mating and of love, just as the human form is hereditarily associated with all our deepest emotions, so that Miranda falling in love at first sight with Ferdinand is not a mere poetical fiction, but the true illustration of a psychological fact. And as on each of our minds and brains the picture of the beautiful human figure is, as it were, antecedently engraved, may not the ancestral type be similarly engraved on the minds and brains of the wading birds? If so, would it not be natural to conclude that these birds, having thus a very graceful form as their generic standard of taste, a graceful form with little richness of coloring, would naturally choose as the loveliest among their mates, not those which showed any tendency to more bright-hued plumage, which indeed might be fatal to their safety by betraying them to their enemies, the falcons and the eagles, but those which most fully embodied and carried furthest the ideal specific gracefulness of the wading type? Forestine flower feeders and fruit eaters, especially in the tropics, are almost always brightly colored. Their chromatic taste seems to get quickened in their daily search for food among the beautiful blossoms and brilliant fruits of the southern woodlands. Thus the hummingbirds, the sunbirds, and the brush-tongued lories, three very dissimilar groups of birds as far as descent is concerned, all alike feed upon the honey and the insects which they extract from the large tubular bells of tropical flowers, and all alike are noticeable for their intense metallic luster or pure tones of color. Again, the parrots, the toucans, the birds of paradise, and many other of the more beautiful exotic species are fruit eaters, and reflect their inherited taste in their own gaudy plumage. But the waders have no such special reasons for acquiring a love of bright hues. Hence their aesthetic feeling seems to rather have taken a turn toward the further development of their own graceful forms. Even the plainest wading birds have a certain natural elegance of shape, which supplies a primitive basis for aesthetic selection to work on. End of section 43. Recording by Linda Dodge.